Welcome to Applied Hydraulics and Pneumatics. Today's topic is speed control circuit. Either of the two basic methods are used for controlling speed of hydraulic motor. First one is variable displacement pump, controls flow to the motor. This configuration is commonly known as hydrostatic transmission. Speed control of hydraulic motor. Here figure shows the circuit. Here you can see that circuit here. I will come back to this later. Figure shows the circuit in which speed control in hydraulic circuit is accomplished using a pressure compensated flow control valve. The operation of the circuit as follows. The spring centered position of the tandem four-way valve, the motor is hydraulically locked. Here you can see that the motor is locked, there is no supply, it is locked. Then here in this system, in the hydraulic motor, so you have a pump, then pressure relief valve, flow control valve which controls the flow. Based on this flow, you can vary the speed of a motor. So, so you can connect either the direction so that motor can be rotated. So either clockwise or counterclockwise direction, both are possible. When the four-way valve is actuated to the left envelope, motor rotates in one direction. Its speed can be varied by adjusting setting of the throttle of the flow control valve. Speed can be infinitely varied as the excess oil goes through the pressure relief valve. When the four-way valve is deactivated, motor stops suddenly and gets locked. When the right envelope of four-way valve is in operation, that is this one, right envelope, this is the left envelope. So the motor rotates in opposite direction. The pressure relief valve provides overload protection when the motor experiences excessive torque load. In hydraulic operated machine tools and other mechanical equipment, speed control is required to enhance the functional versatility of the machine. Speed control required during different strokes can be done by regulating oil flow to the cylinder. So probably in some circuits, so one direction you have to move fast, another direction you have to move slow. So like that, some variation is required. So you have to find out a system to do that. So how the speed control is carried out, so that we can see with some examples. Speed control of a single load can be done using variable displacement pump. If the speeds of a number of loads are to be controlled independently, the metering of the oil to individual cylinder is done by using flow control valves. Depending upon location of flow control valve for metering the oil, speed control circuits can be classified as meter in, meter out, and bleed off circuits. In the meter in circuit, you can the first is let us see the circuit. Here you have a reservoir, filter, pump operated with the help of this motor. Then you have a pressure relief valve. Then you have a direction control valve. Here you have a flow control valve. So it say it allows the oil to flow in a controlled manner based on the requirement. You can send this one controlled manner. At the same time, in the retracted position, the air check valve is there. Then freely oil can flow. It's in the other way around. That is one stroke. That is when this is moving this way, then it is controlled flow will be there. In other direction, it is free flow. Through check valve, the oil can flow freely. This type of circuit consists of a pressure compensated flow control valve between pump and cylinder. This flow control valve is placed in pressure line that actuates the cylinder to work. Oil flowing into the work cylinder is metered through the flow control valve. Since this metering action involves reducing the flow from pump to the cylinder. The pump must deliver more fluid than is required to actuate the cylinder at the desired speed. Excess fluid returns to the tank through relief valve. To conserve power and avoid undue stress on the pump, relief valve pressure is kept little higher than the working pressure. The metering circuit is considered to be better in application where load always offers positive resistance to flow during controlled stroke. These circuits are used where slow speed rates are required. A meter in speed control is shown in figure. Say this is a pressure relief valve. This is a symbol for reservoir or a tank cylinder. It is unactuated position. You can actuate either left or right with the help of what do you say, either a solenoid or a lever or something like that, so that we can vary the flow. That is, the direction of flow can be varied or changed. Since this flow is controlled during say this way, we call it as a meter in. So suppose we have a flow control valve this side. Let us see next. That what you call it as a meter out speed control. This type of circuit flow control valve is installed on the return side of the cylinder so that it controls the cylinder actuation speed by metering its discharge flow. A relief valve is kept a little above the operating pressure, which is required by the type of application. This type of circuit are best suited where work resistance is negative, such as climb milling. These circuits may also be used for overhauling load applications in which workload tends to pull an operating piston faster than pump delivery, like in drilling, reaming, boring, turning machines. The flow control and check valve used in the circuit would allow reverse free flow. A meter out speed control circuit is shown in figure. Here you can see that the earlier the control flow control valve is here. Now this flow control valve is fitted here. Okay. So during this one here outlet the flow is controlled. So inlet through the check valve the oil can flow freely. So that is the difference between meter in and meter out. Bleed off speed control. This type of circuit flow control valve is not directly provided in feed line but is connected to the pressure side as shown in figure. Flow control valve regulates the flow to cylinder by diverting a portion of pump flow to the tank. This type of circuit usually involves less heat generation because pressure on the pump equals to the work resistance during a feed operation. This type of circuit is used for constant load application. Any excess load is developed, then the pressure relief valve opens and excess pressure may be relieved to the reservoir. That is the thing advantage here. Let us see the circuit. Here you can see that pump, all these things are same. So once the excess pressure is sensed, what will happen? Then that will be diverted to the this one reservoir. Compared to meter in and meter out circuits, the bleed off circuit is less commonly used. Figure shows the bleed off circuit with extended stroke control. In this type of flow control, an additional line is run through flow control valve back to the tank. To slow down the actuator, some of the flow is bleed off through the flow control valve into the tank before it reaches the actuator. This reduces the flow into the actuator, thereby reducing the speed of the extended stroke. The main difference between bleed off circuit and meter in or meter out circuit is that bleed off circuit opening the flow control valve decreases the speed of the actuator, whereas in the case of meter in meter out circuit, it is other way around. Okay, that is the main difference. If the The bleed off circuit and the meter in meter out circuit, the difference is opening the flow control valve decrease the speed of an actuator. So that is the important thing. We have to keep it in mind because excess pressure is released to the reservoir. So that's why it's happening like that. Here you can see that when the pressure is built up higher than required, the excess pressure will be relieved. So thank you very much for watching this video. Have a good day.